Talk about polygons today. Anybody ever seen a polygon? You think so? You see them constantly? Good, you should. That's what they are. You'll see one every day. Polygon. Can anyone tell me what a polygon is? Let me see. Okay. Very good. A polygon, triangles and quadrilaterals are examples of polygons. A polygon is a closed plane figure formed by 3 or more line segments. So it has to be closed, and it has to have straight lines, and it has to have 3 or more lines. Why can it not? Why is 2 not good? You couldn't close it. You can't close it with only 2 lines. You have examples of polygons. These on top are polygons. These on the bottom are not polygons. Why is this one not a polygon? Curved lines. It has curved lines. It's not straight. Why is the other one not a polygon? It's not closed and they're curved. Yeah. So by definition, it's just not a polygon. Something else I need you to understand is a regular polygon. A regular polygon is a polygon in which all sides are congruent. There's a word, congruent. Who can tell me what the word congruent means? Same length, same size, same measure, same. Congruent means the same. So which all sides and all angles are congruent. So a regular polygon. Who can think of an example of a regular polygon? Jeremiah. A square. A square would be a regular polygon because all the sides are the same length and all the angles are the same. So it is a regular polygon. Now, raise your hand if you ski or snowboard. Okay? Jonathan, you ever go up the lift called the quad? A quad lift? Chairlift? Yeah? How many people can sit on it? Quad is 4. I don't have it at the place you go. Okay. Quad means 4. So when you see a triangle, you know triangle has how many sides? 3. Quadrilateral, how many sides do you think that has? 4. So technically a square is a quadrilateral, a rectangle is a quadrilateral. Any shape that has 4 sides is a quadrilateral. Now be careful. On quizzes, some of you are going to want to write the word quadrangle. It's not what it is. Don't make that mistake. It's a quadrilateral. Okay? Now, polygons are named by the number of sides and the number of angles. So here's some polygons. We have your triangle, we have your quadrilateral, we have a pentagon, we have a hexagon, we have an octagon. All of those are polygons, every single one. This top row and the bottom row. Now the top row is all regular. Why are they regular? What makes a regular polygon?
All of their sides and their angles are congruent.
All their sides and all of their angles are congruent. And what does congruent mean? Marissa? Same. All the same.
No, the pentagon doesn't.
But it is. These are all the same. If you measured these on the pentagon, they're all the same angles. All the lengths are the same. Yes, really. Sometimes you get some of these that are optical illusions, but they are. Yes.
Are the unregular ones even like octagons?
Yes. Yes, they are. This is an octagon. Any 8-sided closed figure is an octagon. Now, you are just used to seeing octagons drawn as regular octagons. As long as it's got 8 sides, it's an octagon. Just like this is a pentagon. It's got 5 sides. It's closed. It's a pentagon. Okay. First part of your homework. You have a couple different parts to your homework. This is your first part. Tell whether each shape is a polygon. If it is a polygon, tell me its name and whether it appears to be regular or not regular. So first of all, first question, is it a polygon? Lacey? Yeah. Yes, it is. What kind of polygon is it? What? Well, it's not regular, because it appears to be not regular, but give me its name.
Pentagon.
Pentagon, because it's got 1, 2, 3, 4, 5 sides. A 5-sided polygon is a pentagon. Is it a polygon? Leah? Yes. Does it appear to be regular? Give me its name. It's an octagon, 8 sides. 1, 2, 3, 4, 5, 6, 7, 8. 8 sides. It's an octagon. Is it a polygon, Alexis? Is it regular? Does it appear to be regular? I would say it does. Give me its name, Jonathan. Leah. Diamond is not really going to be a geometric shape. Diamond is something you might have on your finger someday. It is. You guys are laughing, but technically it is a square, because it's got 4 sides. All the angles are the same, and all the lengths are the same. So technically, it's a square. But give me the word that we used at the beginning of this thing. Quadrilateral. Quadrilateral. 4-sided shape is a quadrilateral. Is it a polygon, Cesar? Yes. Does it appear to be regular? No, it does not, because why? Torrance? Because all of the sides are not the same length. All of the sides need to be the same length for it to be regular. Give me its name, Christian. Quadrilateral. Yes, a quadrilateral. Okay. Now, that's the first part of your homework. The second part of your homework is a little bit more difficult, and I need you guys all to refocus back in. A rule about geometry, a rule about triangles. Every triangle you've ever seen, when you add up all of the angles on the inside of a triangle, they add up to 180 degrees. That's just, no matter the shape of the triangle, when you add up all the angles, they all add up to 180. So that means that this angle plus this angle plus this angle is what? 180 degrees. So this angle plus this angle plus this angle is what? 180 degrees. So you have two triangles here. So then if we add all of these together, so meaning this one plus this one plus this one plus this one plus that one plus that one, what is my total? Lacey, 360 degrees. So it is safe to say that any quadrilateral four-sided shape, when you add all of their angles together, they total 360 degrees. Okay? Which makes sense because when you have a square, not a very good square, but it's my attempt. What is the measure of this angle here? What's this one? What? Parker. What? 90 degrees. What's this one? What's this one? What's 90 plus 90 plus 90 plus 90? 360. Okay? Oh, watch this, by the way. Instead of these little... Oh, how many triangles do I have? 2. Your mom cuts your sandwiches that way?
I do.
Oh, you do. Okay. So then what is the measure of this angle? Well, I shouldn't say that. You don't know that. What is the measure of these three all together? 180. What's the measure of these three all together?
180.
180. What is the total of the measurements of all of those together? 360. Okay. The number of triangles will determine your total. Yes? No, they are all 90. The measure and angle, they're all 90. Okay, now this is the complicated part. Malcolm designed a wall hanging that was a regular 9-sided polygon. It's called a nonagon. What is the measure of each angle of the nonagon? You can do this without actually measuring them because it's regular. What do we know about regular polygons? What do we know? And they all have equal sides. And what? It's closed. That would be for a regular.
And they all have congruent angles.
All of the angles are the same. We know that all the interior angles are the same. That is by rule. A regular polygon, all of them are the same, the angles. So if we can find just one, we know what all of them are because they're all the same. Does that make sense? Okay. So first thing we got to do. The answer will be the measure of each angle in a nonagon. So our answer is going to be in what? What is the label for our answer going to be? How do you measure angles? Because it says, what is the measure of each angle? Degrees. So our answer is going to be in degrees. The important information is a regular nonagon has 9 congruent sides and 9 congruent angles. So if we find one angle, we got them all. All right. Next thing, we need to make a plan. We're going to make a table. We're going to look for a pattern using regular polygons. And we're going to solve it. So look at this. What is the sum of the measures of this? 180. Because we know it's a triangle, that plus that is 180. Check this out. How many triangles do we have in there? 3. So what do you think the sum of the angles is going to be? Someone need a calculator. What are you going to calculate? What are you going to do to figure out the sum? Somebody that doesn't have a calculator, what would you do? 180 times 3. Why 180 times 3? Why 180 times 3? Yeah, each triangle equals 180. So this plus that is 180. This plus that is 180. This plus that is 180. So if we added 180, or if we multiplied 180 times 3, we come up with what? 540 degrees. Okay, so if we have 540 total, and if this is regular and all of these are the same, it's like I got a big pile of degrees. I have 540 of them. But I have to distribute them evenly, don't I, Jonathan? Right? I have to distribute 540 degrees evenly among 1, 2, 3, 4, 5 sides. I have to think of it as 540 M&Ms. Okay? And I have 5 people I need to split it up with. Well, so how do I do that? How do I solve that problem? What do I do? 540 divided by 5, which is equals 108. That means that this is 108, which means that that altogether is 108, which means that that altogether is 108, 108, 108. Does that make sense? What? That's just for this one. I'm just showing you what we're going to do with the 9-sided one. This is just an example of what we're going to do with the 9-sided. Okay? Yeah, this is practice for the practice. Okay? I know you did. Now, let's look at our chart. Triangle has 3 sides. Quadrilateral has 4. Pentagon has 5. Hexagon has 6. The number of triangles you can break it up into is 1, 2, 3, 4. Obviously, you can only break a triangle into one triangle. Someone see a relationship between the number of sides of a polygon and the number of triangles you can break it into? Look at that chart. What is your relationship? Marissa. It's always 2 less. So a hexagon you can break into 4 triangles. How many triangles can you break into for a 10-sided polygon? 8. What about a 17-sided polygon? How many triangles could you break it into? 15. Okay, so our question is a 9-sided polygon. How many triangles do you think you can break it into? 7. So if you can break it into 7 triangles, the nonagon can be divided into 7 triangles, and we know that all the angles are the same. What do we have to do? We know that there's 7 triangles in there. What is my total number of degrees? How do I figure out the total number of degrees on the inside of that? Yeah, 180 times 7, which is going to be 1,260. So now with my 9-sided shape, I have this big pile of degrees. I have a pile of 1,260 degrees. And how many angles do I have to separate that into, Lacey? Jonathan. How many sides do we have? How many angles do we have in this thing? 9 angles in this thing. It said at the very beginning of the problem, we have a 9-sided shape, which means that there's 9 angles. Okay, so we take that 1,200, 1260 divided by 9, and I'm going to come up with what? 140 degrees. That means that each one of those angles on that nonagon is 140 degrees. That answers the question. 140, yes.
Can you measure angles like that with not regular?
No, you cannot do that with not regular. It has to be regular because otherwise this division doesn't work. We have to divide it into one that we know it's going to be evenly distributed, okay? Now, you're going to have a problem like this on your homework. Sarah designed a picture. Those of you that are struggling, I suggest you get out a notebook and you write these down because I'm going to write down the steps for you. It said, Sarah designed a picture that was a regular 6-sided polygon, okay, called a hexagon. What is the measure of each angle? So we know that each one of the angles of this hexagon are the same. Once we find one, we found them all because it's regular. How many angles are there in a hexagon? Lacey? 6. So, step number 1. Find the number of triangles. And the way we find the number of triangles is the number of sides minus 2. What is the number of sides that we have? 6 minus 2 is 4. So the number of triangles that we're going to have is 4. I hope that you don't have a question with this later. If you're choosing not to write any of this down, I hope you don't have a question later. Step number 2. Take the number of triangles and multiply by what? We're looking for the total number of degrees. Yeah. Multiplied by 180 because that is the total number of degrees in each triangle. So each triangle has 180 degrees. So the number of triangles that we had for this problem is 4 times 180, which equals what? 720. That's step number 2. So now I've got a pile of 720 degrees. I need to distribute that among how many angles? 6. So step number 3 is take step 2 and divide by the number of sides, number of angles. So I have 720 divided by 6, which is 120 degrees. There's my answer. The measure of each angle of the hexagon is 120 degrees. Now, some of you are going to have a difficulty because it's hard sometimes to see the number of triangles, or you maybe don't know how they're doing this. Let me show you something. No, we're still waiting here. Okay. What I do is this, in order to find out the number of, you're looking at these, and I know a bunch of you could just go like this. You could go, oh, wait. And then you want to do this, and then you just don't know. What you have to do in order to figure out the number of triangles, you need to pick an angle, one angle, and draw lines to each one of the other angles. Okay? So this one's a, how many sides is it? 1, 2, 3, 4, 5, 6, 7, 8. That's an octagon. So our rule says that our octagon should have how many triangles? How many do I have? 1, 2, 3, 4, 5, 6. Okay? Yes?
What if you pick another angle? Wait.
It doesn't matter what one I pick. You could, but the idea is you can't ever have the lines cross.
Oh.
You can never have the lines cross, okay? Yes, you could make more, but you just can't have the lines cross, okay? Are there any other questions about that? Yeah. About any of it. If it's not regular, you can't do the whole process we just did because your division doesn't work. Because at the end, you're not distributing the angles evenly because the angles aren't all the same. So it only works if it's a regular polygon. Okay? Your homework. Page 448, 5 to 20 all.